So in this video, we're going to talk about how to use logarithms to solve exponential equations. So remember, we can undo an exponent with a logarithm. So suppose you want to solve the equation 2 to the x equals 55 for x. You can do so by taking the logarithm of both sides. So here are going to be our steps that we use when we try to solve these equations. You're going to start off by isolating the term with the variable. So get the variable term by itself on one side of the equal sign. Then you can take the common or natural log of both sides. So this is going to allow you to eventually use a calculator if you need to find the value. And then we're going to solve for the variable. So let's suppose we want to solve 4 to the x equals 11. So I'm going to go ahead and take the logarithm of both sides. So this is the log of 4 to the x equals the log of 11. So now what I can do is I can use the power property to bring this x down in front. Okay, so this becomes x log 4 equals log of 11. Well, now what I want to do is I want to get that x by itself. Well, the log of 4 is just a number. So what I can do is I can divide both sides by the log of 4, and that will allow me to solve for x. So I'm left with just x equals the log of 11 divided by the log of 4. Okay, so if you want an exact answer, you can leave it like this. If it wants you to approximate, what you can do is you can enter this in your calculator. Okay, so you can go to your calculator, you can type log 11, hit enter, and then divide by log 4, and then hit enter, and it gives you 1.7297. Right, remember logs we usually round to 4 decimal places, so that will be your approximate solution. So it just depends on what it asks you for in the original problem. So let's try solving 7 to the 9x equals 5. Okay, so once again, the term with the variable is by itself. So I'm going to go ahead and take the log of both sides. So I have 7 to the 9x equals log of 5. Okay, using the power property, once again, I'm going to bring this 9x down in front. So I have 9x log of 7 equals the log of 5. And now what I need to do is I need to think about getting x by itself. Well, notice on the left side, I have 3 terms that are being multiplied together. Okay, so I'm just going to kind of switch around the order a little bit. I'm going to rewrite this as x times 9 log 7. Okay, and you'll see why I did that in just a minute. Because now if I want to get x by itself, I can just divide both sides by 9 log 7. Right, I'm going to divide the left side by that and the right side by 9 log 7. So when I do that on the left side, all of this will cancel. And I have x equals the log of 5 divided by 9 log 7. Okay, so that is my exact solution. If I want to, I can approximate it using my calculator. I'm going to do log 5 and then hit enter. But then the 9 log 7, you want to make sure and put that in parentheses. Okay, so log 5 divided by parentheses 9 log 7. So I do divided by and then parentheses 9 log 7. And then I'm going to round to 4 decimal places. So that's going to be 0.0919. Okay, so that is the approximate solution. So suppose we want to solve e to the negative 0.3x equals 5. Whenever you have an e as your base, you want to make sure and take the natural log. So this becomes natural log of e to the negative 0.3x equals the natural log of 5. And then what you can do is use the power property to rewrite. So this is going to be negative 0.3x natural log of e equals the natural log of 5. Well, if you remember from the day we talked about properties, the natural log of e is just 1, right? Because this is one of those situations where you have like log base e of e, and so that equals 1. So that will all cancel itself out. So I have negative 0.3x equals the natural log of 5. So what I need to do now to solve for x is just divide both sides by negative 0.3. So when I do that, I get x equals natural log of 5 over negative 0.3. So that's going to be my exact solution. If I want to approximate on my calculator, I can just type it in. So ln 5 and then hit enter and then divide it by negative 0.3. And that gives us negative 5.3648 approximately. So now you can pause the video and try this example on your own. So suppose we want to solve 3 to the x equals 16. We can take the log of both sides. And then we can divide both sides by the log of 3. So we get x equals a log of 16 divided by the log of 3, which is our exact solution. If we type it in our calculator, you do log of 16 and then hit enter, divided by log of 3, and that's approximately 2.5237. Okay, so this should be 2. Okay, so suppose we want to solve this equation, 2 plus 3 to the x equals 15. So we want to isolate the term with the variable. Okay, so what's different about this compared to the previous problems? You see here we have the term with a variable by itself. Here we have a 2 with this term with a variable. Okay, so we need to get rid of that 2. So we can just use our solving equation strategies to do this. So I'm going to subtract 2 from both sides. And when I do that, I get 3 to the x equals 15 minus 2, which is 13. Okay, now this looks like the problems we've been doing, right? So I can go ahead and do the log of both sides. So log of 3 to the x equals log of 13. So I'm going to bring this x down in front. So I have x log 3 equals log of 13. And then I can divide both sides by the log of 3 to get x by itself. So when I do that, I get x equals log of 13 divided by log of 3, which is my exact solution. But remember, you can always approximate with your calculator. So you do log of 13, enter, divided by log 3, and that gives you 2.3347. And that is the approximate solution. So now you can pause the video and try this example on your own. So once again, we don't have the term with the variable isolated, so we need to add 1 to both sides. After we do that, we're going to take the log of both sides, and then we're going to divide both sides by the log of 5. So we have the log of 14 divided by the log of 5, which is approximately 1.6397. So suppose we want to solve this equation. Once again, we don't have the term with the variable isolated. So we need to do that by adding 3 to both sides. So when we add 3 to both sides, we get e to the negative 3x equals 2 plus 3, which is 5. Since I have an e as my base, I'm going to take the natural log of both sides. So the natural log of e to the negative 3x equals the natural log of 5. So I'm going to use the power property to bring this down. So I have negative 3x natural log of e equals the natural log of 5. Remember that the natural log of e is 1. So I can just cancel that term out. So I have negative 3x equals natural log of 5. Now I can divide both sides by negative 3. And when I do that, I get x equals the natural log of 5 divided by negative 3. So that's my exact solution. I can approximate on the calculator. I just do natural log of 5, hit enter, and then divide it by negative 3. And that gives me negative 0.536, and the 4 will round to 5. So that is my approximate solution. So now you can pause the video and try this example on your own. So here you can see the variable term is not isolated. It has a lot of extra terms with it. It has that plus 1, which we're going to do first. Because remember, when we're solving equations, you usually want to do the add or subtract before you multiply or divide. So I subtract 1, which gives me 3e to the 2x equals 24. The variable term is still not by itself because it has that 3. So I'm going to divide both sides by 3, which gives me e to the 2x equals 8. I'm going to take the natural log of both sides, and I'm going to use the power property to bring that 2x down in front. So I have 2x natural log of e equals the natural log of 8. And then I'm going to divide both sides by 2 because this natural log of e term just becomes 1. So all I'm left with is 2x. Then divide both sides by 2, and I get natural log of 8 over 2. If I do that on my calculator, natural log of 8 divided by 2, that gives me 1.0397. That is my approximate solution. So remember, you can solve an exponential equation using common logs and natural logs. You'll start off by isolating the term with a variable, take the common or natural log of both sides of the equation, and then you can solve for the variable.